Okay, hello everyone. From last two classes, we are discussing numericals on Karl Pearson's correlation coefficient. In our last class, we have been discussed this question in detail. Okay, and this question also we have been discussed in detail. This one, we have been discussed, and I hope similar way you have been already done this second I. Okay, so in this class, today's class, we are going to discuss another two to three numericals upon correlation coefficient, Karl Pearson correlation coefficient. Okay, so let's start. So today's first question is that the variables x, y are connected by the equation this one ax plus by plus c equal to 0. Two random variables are connected by the equation this one, so that the correlation between them is -1 if the signs of a and b are alike, and +1 if they are different. So before we have to start, once again I am going to suggest to all of you that watch carefully the video, then after clearly you have to write down your note. Don't be late. Okay, now here two random variables are connected with the equation this one, and we have to prove that the correlation between them will be -1 if they have same sign, and +1 if they have different sign. So here it is given that ax plus by plus c equal to 0, the equation with the help of which both two random variables are connected with each other. This one. Okay. Now to find out correlation coefficient between the two random variable x and y, the correlation coefficient is nothing but covariance of xy divided by sigma x into sigma y that we know. Here the standard deviation of x, this one is your standard deviation of y. So to find out the covariance of x and y, here the covariance of xy is nothing but expectation of x minus expectation of x into, here one bracket you have to put, okay, another curly bracket, this one, y minus expectation of y. These things already we have been discussed in our previous class. May you can check your note that in our first class, whenever we are discussing the introduction about correlation, in that class we discussed, and also we know in our previous class, whenever we discussed about the properties of correlation in our offline classes. So covariance of two random variable is nothing but expectation of whole expectation of x minus expectation of x into y minus expectation of y, right? So here to finding this one, we need to find out expectation of x, expectation of y. So only for that I have been operated expectation in the LHS with the LHS and the RHS of this given equation. This is your given equation in your question. So what I done, I operated expectation with left hand side, or you can say on the left hand side of this equation and right hand side of this equation. So right hand side will be 0, and expectation of ax will be a expectation of x plus b expectation of y plus c, because expectation of a constant is itself that constant that we know. So we found that this has been modified to this one by applying expectation on both left and right hand side. So if you want, you can write another line that this is the first equation, and here you can write by operating expectation on LHS and RHS, we get that this one. Okay, if you want you can write, otherwise it is very easy to perceivable. Okay, After this line, easy to understand, no problem. So now here you can see that what I done, I have been subtracted these two equations. So after writing this line, you just write by subtracting the two above equations, we get this line. You have to write after writing this line, okay? Then, so now you can see that if we are going to subtract this one from this, we can found here, you can see ax minus a expectation of x, a can be taken outside, so x minus expectation of x plus b into y minus expectation of y equal to 0, right? That implies we can found, and c minus c will be 0, so equal to 0. That implies we can found, here you can see x minus expectation of x will be equal to this term taken this side, RHS side, it will be minus b y minus expectation of y divided by a. So minus b by a, y minus expectation of y. Very easy steps. So now the covariance of xy, as we discussed just now, that will be expectation of whole expectation of x minus expectation of x into, you have to put a curly bracket here, y minus expectation of y. So that equal to, here you can see x minus expectation of x equal to this much, and already y minus expectation of y is there. So this into this will be equal to how much? You can see minus b this one into this one. So as it is a constant, so it will be taken out to the expectation, because initially expectation is there. So minus b by a taken outside. So we found expectation of this one, y minus expectation of y, already y minus expectation of y is there. So y minus expectation of y whole square. So this is whole square, right? You have to write down like this. You have to put a curly bracket like this. Whole square, y minus expectation of y whole square. And we know that expectation of y minus expectation of y whole square is nothing but sigma y square, or variance of y. These things many times we have been discussed. This one, okay, you can check your note, previous note, that is your variance of x is nothing but expectation of x minus expectation of x, that is x mean expectation of x whole square. This is nothing but your variance of x, or you can write sigma x square. Likewise, this will be called as your sigma y square. Now sigma x square will be how much? Expectation of x minus expectation of x whole square, right? So this will be, here you can see that we have the value of x minus expectation of x equal to minus b by a, y minus expectation of y. So this value just I substituted here, okay? So here x minus expectation of x is nothing but this one. So here if I will substitute, then it will be whole square of this one. So whole square means minus will be plus, and b minus sorry, b by a will be b square by a square, itself a constant, can be taken outside the expectation. Here expectation is there, so okay. So b square by a square taken outside, expectation of y minus expectation of y whole square, okay. And we know that expectation of y minus expectation of y whole square is nothing but sigma y square. So instead of this one, we can write sigma y square, or variance of y, right? Now the covariance, the correlation coefficient r will be equal to covariance of xy by sigma x sigma y. So here you can see that we found sigma x square equal to b square by a square sigma y square, right? and your covariance is equal to minus b by a sigma y square. We have to just substitute here in the numerator. We have to write minus b by a sigma y square whole divided by here sigma x square can be written as sigma x square is this one. So sigma x will be how much? Sigma x will be root over of this one. Root over of this one means root over of b square, a square, root over of y square, and sigma y and sigma y can be written as simply root over of sigma y square, right? See here sigma x square equal to this much. So sigma x will be root over of this one, and see for the sigma y simply we can write root over of sigma y square, right? So here we found that here you can see that the denominator will be uh, here you can see that root over of b square by a square will be nothing but b by a modulus, right? If we are going to be consider the root over, then this value will be plus or minus. So in general we can write a modulus of b by a, and the numerator will be minus b by a sigma y square, and the denominator here you can see uh, uh, if we are going to consider root over, this will be sigma y, this will be sigma y, and we are going to get sigma y square, and this sigma y square we got cancel, and we found that minus b by a divided by b by a modulus. Okay, so correlation coefficient we found this one. So here you can see that suppose we are going to consider b and a are opposite sign. So b and a both are opposite sign. So if it is so, then the numerator will be plus, okay, and the modulus always plus. So we are going to get the numerator and denominator will got cancel. We are going to get plus 1. And if b and a are the same sign, so here b is positive and a is positive, you just think. So numerator will be negative. So obviously we are going to get the value, r value will be negative, right? So hence it has been proved. Okay, in which way I told to write down this question in a note, in that way you have to write down. Okay, now we have to go for the next question. Next question is very easy question. If z equal to x plus by and r is the correlation coefficient between x and y, so that sigma z square will be equal to a square sigma x square plus b square sigma y square plus 2ab r is your correlation coefficient into sigma x into sigma y. And b, next question b is your the question is so that the correlation coefficient r between two random variables x and y is given by this much: sigma x square plus sigma y square minus sigma x minus y square by 2 sigma x into sigma y, where sigma x, sigma y, sigma x minus y are the standard deviations of x, y and x minus y respectively. So first we have to go for the question A. Your A is, we have to prove this one. If z equal to this, right? So in the given question it has been given that you can see that uh, z equal to ax plus by. Now we are going to take expectation of both the side of this equation. So we found it is written, no problem. Taking expectation both the side of this equation, we get expectation of z equal to, here a is constant, so a into expectation x plus b into expectation of y. So now we are going to consider z minus expectation of z. So z equal to this much. So that means this minus this. So the left hand side will be z minus expectation of z, and the right hand side obviously it will be, you can see, x minus expectation of x, and a is the common, and plus b into y minus expectation of y. So here we found that z minus ez equal to a into x minus expectation of x plus b into y minus expectation of y, right? Now what we have to do, we have to do that, we have to squaring both the side, and then we have to consider the expectation. Okay, so here in the book, it has been written directly, but you have to write down those one or two steps I am writing here. You just watch that. You have to consider the squaring both the side, and then you have to consider the expectation. That means here it has been given that z minus expectation of z plus a, sorry, equal to a into x minus expectation of x plus b into y minus expectation of y. So what we have to do, we have to consider the squaring both the side and then expectation. Here squaring and taking expectation both the side. That means here we have to consider expectation of z minus ez square, then expectation of this whole a into x minus expectation of x plus b into y minus expectation of y whole square, right? Okay, so here we can found that this is nothing but your sigma z square. Okay, so expectation of z minus expectation of z whole square equal to sigma z square. That means variance of z. Here you can found that expectation of this square, you just remove the square by considering a plus b whole square. That is your a square x minus expectation of x whole square plus b square y minus expectation of y whole square, and here 2 into a into b, x minus expectation of x into y minus expectation of y, right? So these two steps you have to write down, then you have to write this one. Here you can see expectation of this one is nothing but is your a square sigma x square. See, expectation of x minus expectation of x whole square is nothing but sigma x square. And here you can see expectation of b square into this much is nothing but b square into sigma y square. And expectation of this much is nothing but, see, expectation of x minus expectation of x into y minus expectation of y. Here we just discussed in our previous question, this one is nothing but covariance of xy. So here we are going to get plus 2ab into covariance of xy. Same thing, it has been written plus 2ab uh, covariance of x and y. I suggest that before you have to write direct this line, the two steps whatever I done in the paper, that you have to write down. Okay, so here is equal to a square sigma x square plus b square sigma y square. And here you can see that 2 into a into b, so covariance of xy can be written as, here you can see covariance of xy can be written as r into sigma x into sigma y, right? So instead of covariance of xy can be written as 2ab r into sigma x into sigma y. So hence it has been proved. In the question it has been given that you have to prove this one, and we have been proved. Now second bit or b, so that the correlation coefficient r between two random variable x and y is given by this one. So in this expression, see, for this question you have to prove this equal to this one. For this question, that means here z equal to ax plus by. So here we found sigma z square equal to this one. Now we are going to substitute the value of a equal to 1 and b equal to -1 in this above expression, that is sigma z square equal to this much. What we are going to find out, see, in the above case then z will be how much? Z, here you can put z equal a equal to 1, so z will be x and b equal to minus 1, so we can found z equal to xy, z equal to x minus y, x minus y. So hence this one sigma z square can be written as, instead of z can be written as x minus y. Okay, so square sigma z square will be written as sigma x minus y square is equal to, here a is 1, so sigma x square, b is minus 1, obviously sigma y square, and here b is minus 1, so it will be minus 2 into r into sigma x into sigma y. So therefore r, so here we found that uh, this equal to this much, so that implies r will be equal to this much, sigma x square plus sigma y square minus sigma x minus y square by 2 into sigma x into sigma y, right? So hence it has been proved. Next we have to go for the next numerical, that is this one. If x and y are two random variables with variance sigma x square and sigma y square respectively, r is the correlation coefficient of correlation or correlation coefficient between u is equal to x plus ky and v equal to x plus sigma x by sigma y into y, find out the value of k so that u and v are uncorrelated. So here it has been given that u and v are uncorrelated, that means correlation coefficient will be equal to 0, right? So first of all we have to find out the expression of r, then we are going to be equate this r will be 0 and automatically we can found the value of k. So by considering the question, it has been given that u equal to x plus ky, v equal to x plus sigma x by sigma y into y. Now we are going to take the expectation of both the side of this one and expectation of both the side of this one. So here we can find expectation of u, expectation of x, k is constant, so k into expectation of y, and for this it will be expectation of v equal to expectation of x, sigma x and sigma y both are constant because both are standard deviation, so sigma x sigma y taken outside, so e expectation of y, right? Now what we are going to do, that we have to just subtract, see, we have to subtract this equation from this equation and this equation from this equation. So what we are going to find out, so you can do one thing, you just write down in a note that this is your equation number 1, this is your equation number 2, and this is your equation number 3, and this is your equation number 4. And before writing this line, you just write down that subtracting 3 from equation number 1, 3 from equation number 1, subtracting 3 from equation number 1, and uh, uh, 2 minus 4, subtracting 4 from equation number 2, we get these things. You have to write down what we are going to get. So this so 3 is going to subtracted from 1, it will be left hand side, you can see u minus expectation of u, and uh, this is x minus ky minus ex plus ky, means we can get x minus expectation of x plus k into y minus expectation of y. Likewise, if we are going to consider the subtraction of 4 from 2, that means 2 minus 4, we can find v minus expectation of v equal to x minus expectation of x plus sigma x by sigma y, y minus expectation of y. Very easy step. Now we are going to go for the covariance of uv. So here uv are the two transferred random variables by considering this and this relation. So covariance of uv will be nothing but, in general, can be written as expectation of u minus expectation of u into v minus expectation of v. Now what we have to do, we have to just substitute this value here and this value, this one here. Okay, so whole expectation into this value, that is your x minus expectation of x plus k into y minus expectation of y into this one, x minus expectation of x plus sigma x by sigma y, sigma x by sigma y, y minus expectation of y, y minus expectation of y. So here you can see this is whole expectation of these values. So I suggest to all of you that you have to write down another step here. What is that? Just multiply uh, this term with this two term. So we are going to get four terms here. Okay. So what are the four terms? Here I'm writing. You have to also write down in your note. Before you have to write down directly this step, you have to write down another line here. Just simple multiplication is there. So it will be expectation of here. This is going to be multiplied with this one. This one, that will be x minus expectation of x whole square, then plus this one multiplied with this one. So sigma x by sigma y into x minus expectation of x into y minus expectation of y. Okay, then this one k into y minus expectation of y will be multiplied with this one. It will be k into y minus expectation of y into x minus expectation of x. Okay, then plus this term will be multiplied with this one, that will be k into sigma x sigma y into uh, it will be y minus expectation of y whole square, right? Now uh, you written this step, then another step also, no need to write directly, you can write this one, because here you can see that here we have inside the bracket 1 2 3 4 four terms. Expectation of this one is how much? Is your sigma x square, right? So here sigma x by sigma y is your constant, but expectation of x minus expectation of x into y minus expectation of y is nothing but covariance of xy. So sigma x by sigma y into covariance of xy. Okay. Next here you can see k into, here expectation is the expectation of this whole term. That means k is constant taken outside. Expectation of this two term is nothing but covariance of xy. Same thing it has been written, k into covariance of xy. Then expectation of uh, k into sigma x by sigma y. K into sigma x by sigma y is constant taken outside. So expectation of y minus expectation of y whole square is nothing but sigma y square. So we can write k into sigma x by sigma y, sigma y square, right? So before you have to write this line, you just write down this one. Okay. Then we found that sigma x square k, here sigma y got cancelled. We found k into sigma x into sigma y. So sigma x square plus k into sigma x into sigma y plus sigma x by sigma y plus k into covariance of xy. So take sigma x common from these two terms, we can get sigma x into sigma x plus k into sigma y plus you just add this one. So sigma x plus k sigma y by sigma y covariance of xy. Again you have to consider the common this terms. You can see this one and this one is the common term in between this and this, in the both two terms. So we can take this term outside the bracket. So this will be sigma x plus k into sigma y into sigma x plus covariance of sigma xy by sigma y, right? So here sigma x and k sigma y written as usual, nothing changed. And here sigma x plus this one is your what? See, this one is your if see with this term, if I am going to multiply sigma x with the numerator and divide sigma x with the denominator, then we can found covariance of xy by sigma y into sigma x is nothing but is your r into sigma x. Okay, it will better that before you have to write down this one, another line you have to write over here. Before you have to write down this line, what you have to write, that sigma x plus k sigma y, okay, into sigma x is here, sigma x is here, plus sorry, plus covariance of xy into sigma x by sigma y into sigma x. That's it. Okay, so here you can found one thing, that here sigma x, this will be covariance of xy by sigma y into sigma x is nothing but r. This value is nothing but r. So sigma x plus r into sigma x. So sigma x can be taken outside, so 1 plus r. So before you have to write this line, you just write down this one. Okay. Mm, now now here we found that covariance of uv. Here covariance of uv, we found this one, right? Covariance of uv, we found this one, this value, right? Now in the question itself, it has been given that uv are uncorrelated. If uv are uncorrelated, then if uv will be uncorrelated, that means you right, already question it has been given now, so you have to write down if no, you have to write like this. In the question it has been given that, in question it is given that, it is in question it is given that uvr will be r, uvr be uncorrelated. That is you have to write, that is ruv equal to 0. So ruv is nothing but your this one, covariance of xy by sigma x sigma y. So if r will be 0, so obviously covariance of xy will be 0. So here you have to write, in question it is given that uv are uncorrelated, not b, are uncorrelated. So that is ruv equal to 0. That implies covariance of uv equal to 0, right? So here we got the covariance value, uh, covariance of uv, the value we found this one, so this will be 0. So if this value will be equal to 0, that implies sigma x plus k sigma y equal to 0. So k value will be minus sigma x by sigma y. So I suggest in which way I told to you that you have to maintain your note, in that way you have to maintain. Okay, watch the video, and in that way you have to write down your note. Okay, now we have to go for the next question. The random here, it is given that the random variables x and y are jointly normally distributed and u and v are defined is u equal to x cos alpha, y plus y sin alpha, v equal to y cos alpha minus x sin alpha. And so that we have to show that u and v will be uncorrelated if this one, tan 2 alpha will be 2r sigma x sigma y by sigma x square minus sigma y square, where r equal to uh, correlation coefficient of xy, sigma x square equal to variance of x, variance of y is your sigma y square, uv are then r uv then independent. Okay, so covariance of uv, it is directly written, so now you can write directly, no problem. Covariance of uv equal to expectation of u1 minus uv into v minus ev. So here expectation of u already given, this one u equal to this much minus expectation of u. So minus expectation of u, just to do in your rough, you can found that expectation of this one. Okay, expectation of this one into here. You can see that, see what you have to do. This is your u value, and expectation of u value will be how much? It will be, cos alpha is a constant, so cos alpha into expectation of x and plus sin alpha into expectation of y. So if I am going to consider uh, your u minus eu, expectation of u, that means this much value minus this much value. So here cos alpha taken common, and we are going to found x minus ex, and sin alpha taken outside, that means we can get y minus ui. Same thing it has been written. So this is one bracket. And similarly, if we are going to consider expectation of v, and then v minus expectation of v will be this much. Okay, and here you can see that the covariance is nothing but expectation of this much. So here one bracket you have to give. It is not given, by mistake maybe. So in bracket this one. Now either you can do your rough, or you can write down in your note that you just multiply each terms. So here 1 2 3 4, that means if this will be multiplied into, so total 4 terms it will become. So here one term, 2 3 4 terms came. So the multiplication step, either you can check uh, in your rough, or you can write before this step here in your note. Okay, and these things whatever I done, that u equal to this much, expectation of u equal to this much, and subtract this by considering equations, numbering by considering numbering the equations in which way we have been done the previous one. Like that also you can write in your note. So here you can see expectation of x minus expectation of x. Here you can see x minus expectation of x is multiplied with y minus expectation of y. Cos alpha, cos alpha, cos square alpha, cos square alpha. Again, expectation of x minus expectation of x, y minus y expectation of y. That is nothing but covariance of xy. Right now, expectation of, see, x minus expectation of x. Here you can see x minus expectation of x minus is there. So minus, here cos alpha, sin alpha, constant, sin alpha into cos alpha. So this will be, see, this term and this term, when it will multiply, then it will be x minus expectation of x whole square, that means sigma x square. Similarly, we can found whenever we are going to consider the multiplication, this one with this one, it will be sin alpha cos alpha sigma y square, and this alpha multiplied with this one, already expectation is there, so we can found minus sin square alpha into covariance of xy. Right, so covariance of, this is covariance xy term is there, so covariance of xy taken common, so cos square alpha minus sin square alpha. Here sigma x square minus sigma y square. If these two terms we are going to consider, we can found minus sin alpha into cos alpha into sigma x square minus sigma y square. Simple. So here we found cos square alpha minus sin square alpha can be written as cos 2 alpha, cos covariance of xy minus this one. As such it has been written. Right, so uv will be uncorrelated. uv random variables are uncorrelated. That means we are going to consider, suppose u and v are uncorrelated. Uncorrelated means correlation coefficient will be 0 and covariance of uv will be 0. Then it is so, if it is so, then here we calculated covariance of uv equal to this much, so this much value will be equal to 0. Right, so same thing it has been written, this much value equal to 0, and after simplification, simple is that, so this will be equal to this much. That implies tan 2 alpha will be this much. Okay, So hence proved. That means if UV are uncorrelated, then this condition is going to be satisfied. Hence it has been proved. Now this is important step also you have to write down in your note, that in general RUV equal to 0 does not imply that variable u and v are independent. That already we have been discussed. But x and y are given the joint normally distribution. Joint normally distributed, and already we have been discussed in our offline class. If joint normally distributed is given and both are uv are independent, and here correlation coefficient we found equal to 0, so that means x and y also are independent if joint normally distributed has been given in the question. So here we have to stop our discussion. In our next class we are going to discuss another type of question, that is if see here up to this much we have been discussed x and y are two random variables, but if we have x, see the classes and another variable, suppose this is your variable your y and this is your variable x, this type of question is there, and corresponding frequencies are there. So how we are going to find out the correlation coefficient, that we are going to discuss in our next class. So thank you so much for watching this video, and write down your note in which way I have been instructed. Okay, so thank you so much. Thank you.